Okay, so continuing with section 6.1, let's consider oops, oh my goodness. Okay, so let's consider a raised to the nth power, where a is a positive real number. So where a is a positive real number, and n is any integer, i.e. whole number, negative or positive. Negative or positive. Okay, and let's recall a couple things. So a to the pardon me, a to the 0 is equal to 1 for all a non-zero by definition. And then we have that a to the negative number n is going to be 1 over a to the positive number n. So, for example, 3 to the negative second will be 1 over 3 to the positive second, which of course is 1 over 9. Okay. So, for example, so let's evaluate the value of a to the n. So evaluate the value or the values of a to the n for the following. So let's say number 1, we want a is 2. Let's have n be negative 1, 0, 1, 2, and 3. Okay, so we have our base a is 2. So that's 2. And now we have first n is negative 1. So 2 to the negative 1 means 1 over 2 to the positive 1. And 2 to the first power is just 2. So that's 1/2. Now let's do 2 to the 0. Well, any number that's not 0 raised to the 0 is by definition 1. Actually, let me color code this. I don't like having the same color. So I'll call this one green. So next one will be 2 to the, let's do first power. And of course, anything to the first power is just himself. So that's just going to be 2. Then let's do base 2 raised to the second power for n equal to 2. So 2 times 2 is 4. And last but not least, let's do 2 raised to the third power. That's 2 times 2, which is 4, times 2, which is, pardon me, 8. So there we are. Okay, so let's do another one. Subscript number 2, let's say we have the base a is now 3. Let's have n be, once again, negative 1. Negative 1, what am I doing? Negative 1, 0, 1, 2, and 3. Okay, so now let's do the base in, say, blue. So the base a is 3. So we want 3 to the, let's do negative first. So what that means is 1 over 3 to the positive first. And of course, 3 to the first power is just 3, so that's just 1 over 3. Now let's do 3 to the 0th power. Well, anything to the 0th power is 1. Okay, now let's do 3 to the, why is this not scrolling? 3 to the first power. Of course, anything to the first power is just itself, so that's just going to be 3. Then next, let's do 3 to the second power. So 3 squared. 3 times 3 is 9. And finally, let's do 3 to the third power. So that's 3 times 3 times 3, or 9 times 3, which is 27. Okay, last but not least, should I move that up one? Yeah, maybe I'll just go over. Okay, so number 3. Let's say we have that my base A is now 4, and n will once again be negative 1, 0, 1, 2, and 3. So now my base is 4. I have 4 to the, let's do negative first power. So what that means is 1 over 4 to the positive first power. And of course, anything to the first power is itself. So this just becomes 1/4. Now let's do 4 to the 0th power. And anything to the 0th power is just 1. So this will be 1. Now let's do 4 to the first power. Well, anything to the first power is just itself. So that's just going to be 4. Now let's do 4 squared to the second power. So that's 4 times 4. 4 times 4 is 16. And last but not least, let's do 4 to the third power. So 4 times 4 is 16. And 16 times 4 is 64. So we get 64. Okay, I fit it all on the same page. I was worried about that. Okay, so definition. So an exponential function, that's what we're defining, or equation, an exponential equation. So is of the form y is equal to a to the x, where a is greater than 0, it's positive, and x is any number and y is greater than 0. Okay, so for example, let's plot the following functions or the following equations. Keep on using that term functions, but let's just call them equations for now. Okay, so number 1, let's say we have y is equal to 2 to the x. So the way we start out with this is called a t-chart. So I make a t, and I have values for x, and I have values for y, which is 2 to the x. So I usually start with negative 1, then 0, then 1, and then 2. Not sufficient. Okay, so what do I mean by that? So those are the values I'm going to plug in for x. So I have, let's have a base of orange. So this will be 2 to the negative first, which of course is 1 over 2. 1 over 2, which is 1/2. Then I'll have, actually let me write that in purple. And I'll show you why in a moment. Then I will have 2 to the 0. If I plug in x is equal to 0. Okay, so what does that give me? That gives me 1, right? Anything to the 0th power is 1. Then I will have 2 to the first power. Okay. Anything to the first power is just itself, so that's just 2. Then I will have 2 to the second power. Okay, so 2 times 2 is 4. And there we are. So what I'm going to do is I'm going to plot these. So let's do x and y axes. So the x-axis is the horizontal axis, and the y-axis is the vertical. Let's do 1, 2, 3, 4. 2, 3, 4. Actually, no. Let me space those out a bit more. So let's do 1, 2, 3, 4. 1, 2, 3, 4. Negative 1. So this is 1, 2, 3, 4. Negative 1, 0, 1, 2, 3, 4. Okay, so when x was negative 1, y was 1/2. About there. When x was 0, y was 1. When x was 1, y was 2. And when x was 2, y was 4. So what I get then is an exponential function that looks something like so. It grows exponentially. So I would connect all the dots. So this would be 2 to the x. It grows exponentially. Okay, so number 2. Let's plot y is equal to 3 to the x. Okay, so once again, I'll do a t-chart. So I have my values for x. I have my values for y is equal to 3 to the x. So once again, I'll plug in negative 1, 0, and 1. I could plug in 2, but that would bring me all the way up to 9. So I'm not sure if I want to draw something that large. But I suppose I can. What the heck? I'll make it large. So, 2. Okay, so my base, let's have my base be orange again. So this is 3 to the negative first power. So of course that's just 1 over 3. Now I have 3 to the 0th power. Well, anything to the 0 power is 1. Then I have 3 to the first power. Well, anything to the first power is itself 3. Then I have 3 to the second power. So 3 times 3 is 9. So now I need to go up to 9 on my y-axis. So x and y. See, hopefully that's 9. So x is the horizontal, y is the vertical. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we made it 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's do negative 1, 0, 1, 2, 3. Okay, so we have the point. When x is negative 1, y was 1/3. When x is 0, y is 1. When x is 1, y is 3. And when x is 2, y is 9. So this is a very, very steep graph here. This definitely shows what it means to grow exponentially. Okay, so that is the graph of 3 to the x. Not done very well. Let's see if I can draw this a bit better. So 3 raised to the x power. Okay, so note exponential curves grow exponentially, right? They're getting very, very tall, very, very quick. So let's note exponential curves grow exponentially. So exponential curves grow exponentially. Exponentially. Hence the term